Hi Year 11 and welcome back to part 2 of this video, which goes alongside the booklet as you can see here. In the other video we've looked at rusting, ceramics and polymers, composites and alloys. What we're now going to look at is pollution, air pollution in particular, and this idea of complete and incomplete combustion, and then how it can then lead to things like the greenhouse effect, which can then have an impact on climate change and the impact that then has on the environment. Okay, so we're going to be on this page here that says pollution. Essentially, we're going to look at the two types of combustion to begin with. And then we're going to talk about the other types of pollutants that you do need to know and the impact that they can have. So we'll start off with complete combustion. So as you'll know, combustion is just the fancy word for burning. Essentially, you're taking a fuel, you are reacting it with oxygen, and it then produces two products. And you do need to know what products are produced. So complete means you've actually got lots of oxygen available to you. So if, for example, I had methane, which again is a hydrocarbon, it could, for example, then tie into hydrocarbons. There's a real overlap with pollution and other topics. So I've got my methane, I then react that with oxygen, and if complete combustion is taking place, so it means I've got plenty of oxygen, then I would make two products, one of which is carbon dioxide and the other is water. So you need to know the products, you need to know what's also needed, and you might also be asked to balance the equation. So if I do my balancing equations, you know I'd like to do my dotted line down the middle. I then count the number of atoms on each side. So carbon wise over here, I've got 1. Carbon over here, I've got 1, so they're happy. Hydrogen, I've got 4. Whereas over here, I've only got 2. So they're not happy. I've got to sort them out. Oxygen, I've got 2. And oxygen, I've got 2, but I've also got 1 over here. So oxygen is 3. So again, they're not happy. So I'll start with my hydrogens. How do I make 2 become 4? Well, I stick a 2 in front of the water. That means I've now got 2 times 2, which is 4. So my hydrogens are now happy. That also now means I've got 2 oxygens there and 2 oxygens there. So in total, I need 4 over this side. So I would put a 2 there. So you might get asked to write the products of it. You might get asked to balance an equation around it. It's knowing that when you've got plenty of oxygen, all of the fuel does in fact burn. And that is why it's called complete combustion. And it's why you make carbon dioxide and you also make water. When you have incomplete combustion, that essentially means that all of the fuel does not react. So there's not enough oxygen. That means some of the fuel does not burn. And that's why we call it incomplete combustion. And we can make different products as a result of that. So we'll just write that down. So incomplete combustion means potentially less oxygen present, which means the fuel, not all of the fuel reacts. So as a result, you'll make different products. And that's how you can spot it in an equation. So you might, for example, make carbon monoxide. So we should know that mono means 1, mon, oxide means 1. So we've got carbon monoxide, which we know is toxic. It's poisonous. It can stop red blood cells from carrying oxygen. And it does that by binding to hemoglobin in your blood. And that makes it less able to transport oxygen around the body. And that can then lead to fainting and potentially even death. The thing about carbon monoxide though is it's odorless, so there's no smell, colourless, so it's very hard to detect carbon monoxide being produced. We can also make carbon particulates, and that is often referred to as soot. So that's like the dust that you see, the layer that you sometimes see on the back of a bus, for example, that would be soot. And that comes from the fact that not all of the fuel is in fact reacting. And that can lead to problems, which is where this idea of air pollution comes in. So we're going to talk a little bit about the different pollutants and the impact they can then have. So we'll talk about the three we've already mentioned so far. So we've got carbon dioxide gas. So we know that that is what we call a greenhouse gas, which means that it is leading to climate change. It causes, and we talk about it more on the next page, but essentially it's leading to global warming. We're obviously trying to reduce the amount of CO2 we use through different methods like renewable energy resources and things along those lines. We've got carbon particulates. So this soot. So sometimes they won't say particulates, just be aware of that. They'll use the term soot, which can cause, well, it can affect breathing, can't it? So it can cause lung issues if inhaled, respiratory problems, for example, because it can damage and get stuck in the lungs. And it can also cause global dimming. And global dimming is where we have less light reaching the surface of the earth. And that's because the particulates, the soot, stays within the air. And I don't know if you've seen recently in the news with New York, they've had the wildfires, which has brought with it lots of soot. And that has then created this layer where the light doesn't reach the surface of the earth, and it's created global dimming. So they're obviously both bad for the environment. Carbon monoxide we've already talked about in terms of the fact that it's toxic, stops red blood cells from carrying oxygen. There are two other pollutants that come around that you need to be aware of that are basically sulfur dioxide and nitrous oxides. So we're going to look at those two now. So sulfur dioxide, its name again gives it away. So S-di means two oxygens. Now sulfur dioxide basically comes from impurities of sulfur that are sometimes found in coal deposits. And when you've got the impurities of sulfur within the coal, and we then burn the coal, the fossil fuels, to generate electricity, that then causes combustion to take place, which we know is where oxygen then reacts with the fuel. And as a result, you produce sulfur dioxide. So you've got sulfur plus oxygen going to make sulfur dioxide. And you need to know about sulfur dioxide in terms of what it is. So first of all, this is an oxidation process. It's been a long day. Oxidation, I can't speak. Oxidation process where oxygen is being added to it. And the sulfur dioxide is a gas, and it can then go up into the atmosphere where it mixes with water within the clouds. And that then produces sulfuric acid, which you'll know as acid rain. And the acid rain then falls down, and it can lead to the corrosion of buildings and kills plants and things like that. So it can lead to corrosion and damaging plants. It could lead to rivers becoming more acidic, so therefore life can't be as well. So what I also want to point out is you've also got nitrous oxides, and they come in different ways. So you might have nitrous monoxide, you might have nitrous dioxide, trioxide, they're all nitrogen oxides, okay? And these guys are usually produced within a car. So when you've got the car and it is, you put your fuel into the car, air then enters through the radiator there. So you've got your oxygen and your nitrogen going into the car. And because of the heat, they react together to form the nitrous oxides, which then come out of the car exhaust. And the nitrous oxides can also cause acid rain because they can mix with water in the clouds, form acid rain and fall down, so nitric acid they can make. What they also, though, are well known for are it can be harmful to humans in terms of it damages the lungs, and it's thought to be linked to a large number of deaths, for example, in built-up areas like cities like London, where the nitrogen oxides are in the air and people are breathing them in. It's damaging the lungs and leading to bad human health, essentially. So that's your main types of pollutants in terms of how they're formed and what they cause. And that's how you need to know it. You need to know how are they formed and then what is the impact they have within the environment. The final thing we're going to look at in this video is the greenhouse effect. Again, I've seen this come up as a 4 marker where you've got to describe the process in terms of infrared radiation. So it is important that you do and you are aware of that. So if you've ever been in a greenhouse, you'll know that it's exceptionally warm inside the greenhouse, and the glass of the greenhouse is essentially being related to that of the greenhouse gases. You need to know what the greenhouse gases are. So we'll start off with that. So the greenhouse gases you need to be aware of are carbon dioxide, methane, which comes from farting cows, so CH4, and water. So they're the 3 that the specification tell you about. We obviously are increasing the amount of carbon dioxide through burning fossil fuels, so it could link to complete combustion. Methane is an alkane, so you could have links to fractional distillation here. It's also produced when you've got rice crops, for example, produces a large amount of methane, and water vapour as well. And they essentially act like the glass, so they form a layer. So as you can see in the diagram, they are the dotted line all around the outside. So that layer is present, and when we have the sun emits, so we know emit means gives out, infrared rays. Okay, so infrared is what causes the heating effect. So infrared radiation, and it is at a short wavelength. And that's the difference. So when you've got short wavelengths, actually it can pass through the greenhouse gases, which is why it reaches the surface of the Earth. However, when the short wavelengths hit the surface of the Earth, they are then reflected as long waves. Okay, so long wavelengths of infrared are then reflected. Now, long wave infrared radiation cannot pass through the greenhouse gases as easily. And essentially they re-radiate, so bounce back down that infrared radiation, which is then leading to the warming effect, global warming. Okay, so we're going to talk about that now. So step 1, we've got our short wavelengths, infrared radiation is emitted from the sun and reaches the Earth's surface, where it is reflected, and you need to tell them that it's reflected as long wave infrared radiation, which is then blocked, or should I say re-radiated by the greenhouse gases. Because it's a long wave, and it gets re-radiated in all directions, and some of it goes back down to the Earth, which long wave radiation is what causes the heating effect, so it leads to the warming. And that is the greenhouse effect. So types of questions, I've seen it be a 4-marker on a higher tier paper. I've seen it be a ticky box question on a foundation tier paper. It's knowing that short comes first, so short wavelengths go in, they then get reflected as long. Short wavelengths can pass through the greenhouse gases, whereas longer wavelengths are re-radiated back down towards the Earth. In fact, it's in all directions, and that's what then causes the warming effect. Now, that then can lead to climate change, which is where the planet is getting warmer, and you have to then be able to describe the impact of the greenhouse effect. So we know that it's causing flooding. We know that it's causing ice caps to melt. This is where you have a bit of an overlap with biology, actually. So ice caps to melt, we know that it causes damage to habitats. That's then having an impact on the number. It's leading to potential endangerment of animals. Extreme weather. You've got lots of different things that have happened as a result of climate change. But it's the greenhouse effect that then causes the warming effect, which then is the impact of this, is these types of things. Okay, so that is everything from me in regards to pollution and greenhouse effect. Hope you found the videos useful. It is the last video that I've had to make for paper 2. So I hope you found them useful, and I wish you all the very best for your chemistry paper 2 exam. Thank you.